Have you ever wondered what it would be like to meet your end on other planets? Today, we're taking a terrifying journey through our solar system to discover the unique ways each planet would kill you. From being roasted alive to crushed by impossible pressures, let's explore the deadly realities of space exploration. Mercury, the closest planet to the Sun, is a world of deadly extremes. If you think being close to the Sun means constant heat, think again. At night, temperatures plummet to a bone-chilling minus 290 degrees Fahrenheit. But during the day, they skyrocket to a furnace-like 800 degrees Fahrenheit. This extreme temperature swing happens because Mercury has virtually no atmosphere to regulate heat. Just a paper-thin exosphere that's useless for temperature control. The real killers here are solar radiation and the complete lack of breathable air. Mercury receives nearly 7 times the solar radiation that Earth does, enough to cook you in minutes. As the smallest planet in our solar system, Mercury is covered in craters, cliffs, and jagged terrain, making it nearly impossible to land safely. The lack of atmosphere means no air resistance to slow down your spacecraft, dramatically increasing your chances of a high-speed crash. Landing during the day is suicide. Even NASA's most advanced spacesuits can only handle up to 250 degrees Fahrenheit. Nowhere near Mercury's daytime inferno of 800 degrees. And remember, Mercury's day lasts about 88 Earth days due to its slow rotation. Night isn't much better. At minus 290 degrees Fahrenheit, you'd be well below NASA suit limits of minus 250 degrees. Your best bet would be the Terminator Zone, the twilight area between day and night, where temperatures are more moderate. But even there, temperatures shift rapidly as the planet rotates, giving you maybe minutes before you're either frozen solid or cooked alive. Venus, our so-called sister planet, is actually hell incarnate. Sitting just 25 million miles from Earth, it seems like it should be hospitable. Its size and gravity are similar to Earth's, so that's not the problem. The first sign of trouble would be those beautiful, thick, yellow clouds you'd see approaching the surface. They're not water vapor. They're concentrated sulfuric acid that would dissolve your lungs in seconds. Even if you had a suit advanced enough to filter it out, you'd face other horrors. As you descend, visibility drops to nearly zero. The atmosphere is 96% carbon dioxide and incredibly dense. So thick that only 10% of sunlight reaches the surface, leaving the planet in perpetual twilight. Then there's the heat, a constant 900 degrees Fahrenheit across the entire planet. Moving would be like wading through honey because the air is so dense, despite gravity being nearly identical to Earth's. But the real killer is pressure, 92 times Earth's atmospheric pressure, equivalent to being 3,000 feet underwater. Even with the best pressurized suit, you might last a few seconds before the crushing force collapses your protection. If somehow the pressure didn't kill you, breathing sulfuric acid once your suit failed definitely would. Mars seems almost welcoming compared to the previous 2 planets. It's the second closest to Earth and considered the most potentially habitable. Daytime temperatures can reach a relatively comfortable 68 degrees Fahrenheit in some areas. But don't be fooled. The real challenge comes at night, when temperatures plummet to minus 195 degrees Fahrenheit. Like Mercury, Mars has an incredibly thin atmosphere, mostly carbon dioxide with only trace amounts of oxygen, so there's virtually no breathable air. This thin atmosphere creates 2 major problems: extremely low pressure and massive radiation exposure. The average radiation level on Mars is 40 to 50 times higher than Earth's, enough to give you fatal radiation poisoning in weeks rather than years. Mars also experiences frequent planet-wide dust storms with winds reaching 60 miles per hour. These storms can last for months, blocking solar panels and creating navigation nightmares. The dust is incredibly fine and gets into everything, potentially damaging equipment and creating respiratory problems. Your best chance of survival would require a completely airtight, well-insulated habitat with a sustainable life support system. Without it, you die from radiation exposure, suffocation, or hypothermia within days. Jupiter is where things get truly terrifying. As the largest planet, it's also one of the most hostile to human life. The radiation alone would kill you 186,000 miles away from the planet before you could even see its famous Great Red Spot clearly. But let's assume you have a magical radiation-proof suit. Jupiter's gravity is 2.4 times stronger than Earth's, meaning you'd be falling at incredible speeds. As you enter the atmosphere, you'd encounter white clouds of frozen ammonia crystals at minus 240 degrees Fahrenheit, with winds screaming past at 300 miles per hour. If you manage to fall about 90 miles through these layers, you reach the deepest point ever explored, the limit of NASA's Galileo probe in 1995. Beyond this, things get exponentially worse. After hours of falling, you'd encounter Jupiter's bizarre inner layers, where matter exists as a supercritical fluid, neither liquid nor gas. You'd be swimming through this strange substance as pressure builds to unimaginable levels. Continuing toward the center, you'd hit metallic hydrogen, an extremely dense liquid that would trap you completely. If you somehow pushed through to Jupiter's core, temperatures would reach 43,000 degrees Fahrenheit, nearly 4 times hotter than the sun's surface. The pressure near the center is estimated at 100 million times Earth's atmospheric pressure. Saturn, the ringed beauty of our solar system, is deceptively deadly. With 146 known moons orbiting around it, your first challenge would be avoiding a collision with one of them at high speed. Then there are the famous rings, beautiful from a distance, but up close, they're debris fields of ice, rock, and metal, traveling at thousands of miles per hour. One small piece could puncture your spacecraft and end your journey instantly. If you somehow navigate through this cosmic obstacle course, you'd witness Saturn's incredible red and purple auroras caused by highly energetic particles. But this beauty comes with hurricane-force winds blasting 1,100 miles per hour, making controlled descent nearly impossible. Entering from the North Pole wouldn't help. There, you'd encounter a massive storm, so large that 2 Earths could fit inside it. This region has ammonia clouds similar to Jupiter's, with temperatures dropping to minus 300 degrees Fahrenheit. As you fall deeper, temperatures rise, but pressure becomes your worst enemy, eventually reaching levels comparable to Earth's deepest ocean trenches. The gases around you would transition into liquid form as you're compressed. At Saturn's center lies a molten rocky core about 10 times the size of Earth, with temperatures reaching 21,000 degrees Fahrenheit, more than twice as hot as the sun's surface, with pressure roughly 1,000 times greater than Earth's. Uranus is where planets start getting really weird and really far from Earth. As one of the ice giants, it's the only planet that spins on its side, rotating faster than Earth, with days lasting just 17 hours. Being an ice giant doesn't mean it's a solid ice ball. It means it's primarily composed of elements heavier than hydrogen and helium. You'd still need to navigate through rings, though they're much fainter than Saturn's. Once past them, you'd be surrounded by toxic gases as temperatures drop rapidly to below minus 350 degrees Fahrenheit, making Uranus the coldest planet in our solar system. The freezing cold and poisonous atmosphere would start killing you immediately. Ascending through the first atmospheric layer, the air becomes incredibly dense and you'd be pelted by ice particles. But then you'd encounter something truly spectacular. Diamond rain, created by extreme pressure breaking down methane, with winds reaching 560 miles per hour. The pressure here is about 100 times greater than Earth's, which would ultimately crush you long before you could appreciate the deadly diamond shower. Neptune, our solar system's outermost planet, is essentially Uranus's twin, with some key differences. Being 30 times farther from the sun than Earth, it's incredibly dark and cold in its outer layers. Like Uranus, Neptune experiences the famous diamond rain phenomenon, but its winds are among the strongest in the solar system, reaching supersonic speeds that would tear apart any spacecraft. The outer layers are extremely cold, but the inner layers are intensely hot due to immense pressure and heat from the core. Neptune's core temperature reaches about 12,600 degrees Fahrenheit, hotter than the sun's surface. The combination of supersonic winds, diamond rain, crushing pressure, and extreme temperatures makes Neptune a particularly creative way to die. You'd be simultaneously frozen, crushed, and eventually incinerated. So there you have it. 8 unique and terrifying ways our solar system could kill you. From Mercury's temperature extremes to Neptune's diamond storms, each planet offers its own special brand of cosmic death. The universe is beautiful, fascinating, and absolutely determined to kill us in the most creative ways possible. Makes you appreciate Earth's cozy, life-supporting atmosphere a bit more, doesn't it? Thanks for joining me on this deadly tour of our solar system. Subscribe for more terrifying space content, and let me know in the comments which planetary death you think would be the worst way to go.